Okay, don't ask me why I'm doing this because anyone with the right mind will know that the answer is 1 and e to the power of plus or minus I 2 power 3, I think. Yeah. So, anyway, z cubed equals to 1. Don't tell me that's 1. There's 3 solutions to it. So, if we let z equals to a plus bi, yeah, you probably can see where this is going next. We have a plus bi cubed equals to a cubed plus, what is it, 1331, so that's a square plus bi plus, okay, this is no good, plus a b squared I squared, okay, that was split on negative, and then plus b cubed I cubed, so get rid of that becomes negative. So that equals to a cubed minus 3ab squared plus I of 3a squared b minus b cubed. So if this is equals to 1 plus 0i, because why not? So therefore a cubed minus 3ab squared is equals to 1 and 3a squared b minus b cubed equals to 0. So in our special class, we had a saying called you have two variables and you have two equations. If you're good enough, you can solve it. Totally disagree because this is not a linear equation. But anyway, let's just keep going. So we have 3a squared b equals to b cubed. A equals to skipping steps over 3b. Yep, that looks about right. And we can cancel the one of the b out. That'll just make life much easier. B squared over 3. Oh, okay then. That's b. Does b has to be a positive number? Okay. Square root actually is an absolute value of b. Yeah. Shouldn't make that mistake, but anyway, over root 3. Okay. So substitute this thing back in there. We will get absolute value of b over root 3 cubed minus 3 times the absolute value of b over root 3 b squared equals to 1. Hooray! What an ugly equation. Have to solve. Yeah. This is not good. Can I just assume b is positive? No, I can't because could be negative. Yeah, I can't. So this will give me absolute value of b cubed. I don't know why I'm doing this. Over 3 to the power of 3 on 2. Minus, what is it? So 3 times b absolute value b squared over root 3 equals to 1. Alright, okay, I'm head down for this. Assuming b is positive. Alright, okay. B cubed over 3 root 3 minus 3b cubed over root 3 equals to 1. Wait, what? Okay then. B cubed of 1 minus 3 root 3 minus 3 root 3. Wow, okay. 9, 3 equals 1. B cubed of minus 8. Okay, that's weird. Yeah, I started questioning myself. Oh, maybe not. Yeah, b cubed is equals to 3 root 3 over negative 8. And b is equals to the cube root. But a and b has to be a real number because it's the components, real and imaginary components of the complex number. So if we cube root this one, we don't have to worry about a bunch of random things popping out. So this is equals to root 3 on 2 minus, yep, negative 8. This is going to be fun. So we have root 3 on 2. And that's correct. Oh yeah, that's actually correct. Okay, so if I b equals to a root 2, then we will have a equals to the magnitude of this, which is just itself, over root 3. So wait, hang on. What? Am I getting this correct? Yeah, divided by this. Oh yeah, so a is equals to a half, right? Oh yeah, okay. So now we can say, because that's an absolute value, so I could also say that's a negative a half, or a negative a half, then b could be or a negative 1 on 2, just because of the symmetry. I'm cheating, but anyway. So z cubed equals to 1, z is equals to 1 from common sense, or a half plus root 3 on 2i. Wait, hang on, negative a half. Oh no. Yeah, okay, this is not good, because I just square rooted it, so there's a plus or minus sign at the front. Then I probably don't really care about the absolute value, because I got a plus or minus at the front anyway. So yeah, okay, using common sense, we get this, or 1 on 2 minus root 3 on 2i. And when I say common, I keep saying common sense, because if we have a complex number solution, if one of the solution is here, so first solution is here, and because that we are cubing it, the second and third solution should be there, and they should form a nice 120 angle to each other, or pi on 3. 2 pi on 3 angle with each other. So yeah, that's how you get the solution with this negative sign. Embarrassing, got that wrong. But anyway, you get the idea. So it is still doable without using the Euler's magical formula, but yeah, interesting.